Okay, welcome to today's tutorial. In this video, we're looking at the resultant of more than two vectors, right? So, the resultant of more than two vectors. So, if we have more than two vectors, how do we resolve them? How do we look for the resultant? So, to find the resultant of more than two vectors, we resolve each of the vector into a horizontal component and a vertical component, right? So, here are four forces acting at a point O. So if we are to look for the resultant of these four forces, we would have to resolve each of the force F1, F2, F3, F4 into a horizontal component and into their vertical components, right? So that's how we look for the resultant of more than two forces. So in looking for the resultant of more than two forces, it is very important that you should note this. So for the vertical component, right? For the vertical component, which would represent as y. The y-axis above the horizontal line is positive, and so sine theta is positive. The y-axis below the horizontal line is negative, and so sine theta is negative. So when we are resolving more than two forces or more than two vectors, we resolve them into the vertical component and the horizontal component, right? So for the vertical component, anything above this horizontal line is positive, and anything below this horizontal line is what? Negative. And when we are resolving them, we would use sine theta, right? For the vertical component. Then for the horizontal component, this is for the horizontal component. This is for the horizontal component, and we represent it as what? X. The x-axis on the right side of the vertical line is positive, and so cos theta is positive. The x-axis on the left side of the vertical line is negative, and so cos theta is negative. So what we are trying to say here is that when we are resolving vectors into their horizontal component, anything on the right side of the any vector on the right side of the vertical line, this is the vertical line, right? Any vector on the right side of the vertical line is positive, and anything on the left side of the vertical line is negative. And when we're resolving vectors into the horizontal component, we use cos theta, right? So let's use an example here. Let's look at this example to explain this concept better. So the question that I have here is to calculate the resultant of five coplanar forces of value 10 Newton, 12 Newton, 16 Newton, 20 Newton, 15 Newton acting on an object at O. So acting on an object at O as shown in the figure below. Calculate the resultant of five coplanar forces. What are coplanar forces? Co-planar means that they are working on the same plane. They are acting on the same plane. Just as we have co-workers. Co means the same. Workers. Co-workers, they are working in the same place. That's how we also have co-planar forces. Forces acting on the same plane, right? So we have five co-planar forces here, and these are their values. So we are asked to look for the resultant of these five coplanar forces. And remember what I said, that to find the resultant of more than two forces or more than two vectors, we resolve each of the vector into a horizontal component and a vertical component, right? So we would have to resolve each of these forces into their horizontal component and their vertical component, right? So first of all, we would have to resolve them into their horizontal component. So for the horizontal component, we will represent that as x. So x will be equal to, which is the horizontal component, will be equal to, the first force that I have here is 12 Newton, right? And these forces will always act towards the horizontal line. They will act towards the horizontal line, and they will not cross the vertical line, right? So for this first force, which is 12 Newton, it will act towards this horizontal line, right? So the angle at which it will act is what? 50 degrees. So that will be 12 So for the horizontal component, we use cos theta, right? So that will be 12 cos 50 plus the next force that I have is 10 Newton. 10 cos 0. So why is it 0? Because this 10 Newton, this force of 10 Newton is on the horizontal line, right? Is on the horizontal line, and there is no angle at which where it is acting. And you cannot take it from this point down to the horizontal. You know why? Because the angle at which any of the forces is acting must not cross a vertical line, right? So that will be cos 0. Plus the next force that I have is 15 Newton, and it will act towards where the horizontal. So if here is 30, you should know that this entire place is what 90 degrees. So if here is 30, here will be what 90 minus 30, and that will give us what 60 degrees, right? So it will act towards this what angle. So that will be plus 15 cos what 60 plus the next force that I have is 16 Newton, and it will act towards where the horizontal, right? From here down to the horizontal, and from here to here is what 90 degrees. 30 plus 60, that will give us 90, right? So that will be 16 cos 90. So the next force that I have is 20 Newton, and it is on the left side of this vertical axis. Remember what I said from here, that in resolving the forces to their horizontal component, in resolving these forces to the horizontal component, anything on the left side of the vertical axis will be what negative. So any force that is on the left side of the vertical axis is what negative. So that will give me minus 20 cos what? It is acting towards the horizontal. Cos what? Cos 40. Right? So that's that for the horizontal component. So I will have to bring my calculator on this point. Cos 50 is what? Cos 50 is equal to 0.642787697, right? Times 12. Times 12, that will be equal to 7.71, right? So that will be 7.71 plus, I have 10 cos 0 here, right? So cos 0 is what? Cos 0 is equal to 1 times 10 will give me 10. So that will be plus 10 plus 15 cos 60, right? So cos 60 is equal to, sorry, so cos 60 is equal to 0.5. So 0.5 times the 15 times 15 times 15 is equal to what? 7.5. So that will be 7.5 plus 16 cos 90. So cos 90 is equal to what? 0 times 16 is equal to 0. So that will be plus 0 minus 20 cos 40, right? So cos 40 is equal to this times 20 is equal to 15.32, right? So minus 15.32, right? So if I bring out my calculator, 7.71 plus 10 plus 7.5 plus 0 minus 15.32, that will give me 7.71 plus 10 plus 7.5 equal to minus 15.32. That will be equal to 9.89, right? So that would be equal to what? 9.89 Newton. So this is my horizontal component. So having gotten this, the next thing I would look for is my vertical component. And my vertical component I will represent as y. So that will be equal to. So for the vertical component, we use sine theta, right? And remember, anything above this horizontal line for the vertical component is positive, and anything below is what? Negative, just as we have in a normal graph. So for the vertical component, the first force that I have here is 12 Newton. So that will be 12 sine, it is acting towards where? The horizontal line, 50. So that will be 12 sine 50 plus the next force is what? 10 Newton plus 10 sine what? Sine 0, because all the forces are supposed to act towards the horizontal. So if they are supposed to act towards the horizontal, this is the horizontal itself, and so there is no angle at which this 10 Newton is acting. So the next force that I have what is 15, and this will be minus, because for the vertical component for y, for the vertical component y, anything above this horizontal line is positive, and anything below this horizontal line is negative, right? That is how it is in a normal graph. You would have 1, 2, 3, 4, 5, 6, and so on. And here you will have -1, -2, -3. So anything above is positive, anything below is negative. So that is why I have -15 there. So this will be -15 Newton, and it is acting towards what? The horizontal. So the angle at which it acts is what? 60 degrees. So that will be sine 60. The next force is what? 16 Newton. That will still be minus because it is below this horizontal line. So that will be -16 sine what? Sine 90, because it will act towards where? The horizontal. And we have 30 plus 60 here, so it will act towards the horizontal. Plus the next force is what? 20. It is plus because it is above the horizontal. It is above this horizontal line, right? So plus 20 sine what? Sine 40, because this is the angle at which it acts. So if I bring out my calculator, 12 sine 50 would give us what? So sine 50 is equal to 0.766 times 12. That will give me 9. That will give me 9.19, right? 9.19 plus sine 0 is what? 10 sine 0. So sine 0 is equal to 0 times 10 is what? 0. So that will be plus 0 minus sine 60 is equal to what? 0.866 times 15 is equal to what? 12.99, right? So that will be 12.99 minus sine 90 would give me 1 times 16 will give me 16, right? So that will be minus 16 plus sine 40. Sine 40 will give me 0.627 times 20 will be equal to 12.856, right? So that will be 12.86, 12.86, right? So if I sum that up, that will give me 9.19 plus 9.19 minus 12.99 minus 16 plus 12.86. So that will be equal to minus 6.94. So my Vertical component is equal to what? 6 minus 6.94, right? Minus 6.94. So what I have in essence is that I have a horizontal component and I have a vertical component, right? And the resultant will be represented by this, right? So this is my horizontal force, which is what? 9.89 Newton. And this is my vertical force, which I've gotten to be minus 6.94. And this is my resultant, right? So from Pythagoras theorem, my resultant from this diagram will be equal to the square root of s squared plus what? Y squared. So this will be equal to the square root of my x is 9.89 squared plus my y is what? Minus what? 6.94 what? Squared, right? So if I bring out my calculator again and punch that 9.89 squared, that will give me 9.89 squared is equal to 97.8121. So my arrow, my resultant will be equal to the square root of what? Of 97.8121, 97.8121 plus, so minus 6.94 times minus 6.94 is equal to 48. Minus times minus will give you plus, right? So that's how we have this plus here. Minus times minus plus. So that will give us 48.1636. 48.1636. So 48.1636 plus 97.8121, that will be equal to 145.9759. 145.9757. So that will be equal to the square root of 145.9757. Right? So the square root of 145.9757 will give us square root of 145.9757 will be equal to 12.1. So the resultant force is equal to what? 12.1 Newton. So my resultant here will be equal to what? 12.1 Newton. This is our answer to this question, right? So that is the resultant of the 5 coplanar forces acting at the point O, as shown in this diagram. So just a quick recap. In resolving vectors that are more than 2, we resolve them into the horizontal component and the vertical component. The horizontal component will represent as x, the vertical component will represent as what? Y. So after resolving them into the horizontal and vertical component, the resultant will be equal to the square root of s squared plus what? Y squared, according to Pythagoras' what? Theorem. And when resolving them into their vertical and horizontal component, to the vertical component we use sine theta, and in the vertical component anything above this horizontal line is positive and anything below this horizontal line is negative. For the horizontal component, anything on the right side of this vertical line is positive and anything on the left side of this vertical line is negative, and we use cos theta in the horizontal component. And this example explains everything better, right? So in the next video, we're going to look at this example. Thank you very much for listening. God bless.